everybody, hope you're doing great today. We're going to go ahead and finish up our set of topics on validity and soundness this week. Remember last week we talked about validity and soundness a bit. The idea was we're trying to figure out the difference between good arguments and bad arguments, right? We're trying to figure out which inferences, right? And that's what arguments are making explicit. Which inferences are good and which inferences are not good, right? And the idea was, for any argument, we could ask two questions. We could ask, are the premises actually true? And then we could ask, okay, supposing they're true, do they actually entail the conclusion in question, right? So for like a scientific argument, we could ask, is the evidence itself accurate and legitimate? Or is the data itself accurate and legitimate? And then we could ask, now, does that data or that evidence actually lead to the conclusion you think it does, right? And we could do that for all sorts of topics, right? All sorts of different arguments that we looked at over the past couple weeks. So the idea is, if we have true premises and we have a valid argument, then we can be confident that the conclusion is true, right? Because a valid argument is one that says it's impossible for the conclusion to be false if the premises are true. And then add to that true premises and, well, shoot, it's impossible for the conclusion to be false. So when we have both of these things, right, we call it a sound argument, and that's really what we're after. We're after trying to find sound arguments, right? Arguments that start from good places and only take good steps, right? And last time we looked at 4 different combinations of that sort of thing, right? Something that does both right, that's valid and true premised, so it's sound. And then we looked at the 3 ways that could fail, right? Just having false premises, just having it being invalid, and then it being invalid and having false premise, right? It failing both. And we looked at a few examples of that as well. So the idea is, for any argument, we can always ask these 2 questions. Is it valid, right? Do the premises entail the conclusion, regardless of if they're true in the real world? And then we can ask, okay, now, are they actually true in the real world? Right? So one of these is an actual real question, or a question about the real world, and the other one is a hypothetical question about what's even possible. Okay, so we're going to be digging more into that this week, right? And the idea is, so I'm going to bring up this list of arguments, and what we want to do is understand a bit more about validity. So validity in particular, like I talked about at the very end last time, is really going to be the main concept we're going to be concerned with in logic. The others are also important, but like you'll begin to see why we really care about validity. It's validity. One reason is that validity is what, right, really concerns the inferences, right? So set aside what you're starting with. Or does what you're starting with actually justify where you're going, right? So we're interested in the connection between our reasons and the conclusion. And it's important to realize when we're talking about this that there's also that question about where you're starting with in the first place. But it's that connection between your starting points and your conclusion that we're going to be really interested in over the course of the semester. So today what I want to do is I want to start off with just looking at a handful of arguments, and we're just going to, together, we're going to try to think about, are these valid arguments, right? Are these arguments that we think, yeah, if their premises were true, I'd accept the conclusion, right? And so let's go ahead and get into that. So first off, if it rains, then the ground will be wet. It is raining, therefore the ground will be wet. Okay, so what do you guys think? Is there any way, if these 2 things were true, is there any way we wouldn't want to accept the conclusion? So if it was raining outside, or if it were raining outside, and if this were just a true rule, right, when it rains, the ground is wet, right, essentially, then do we have to believe that the ground will be wet? Sometimes it like you might already be answering intuitively, and generally speaking, all we can do at this stage is really just pump our intuitions, and that's fine. We're going to be, again, over the course of the semester, working through this and trying to get beyond our intuitions, but we have to start somewhere, right? But one way to do this is to ask, okay, suppose I think this is false. Suppose I think the ground is not wet outside, right? is there any way that that could be true while these were true? Right? Or if this were false, what would that mean for these first two statements? So suppose the ground is not wet outside, or will not be wet outside. Suppose it will be just dry constantly. Then that means, well, either it's not raining, because raining leads to the ground being wet, or maybe it is raining, but it raining doesn't actually lead to the ground being wet. Right? Like, so the point is, the only way for this to be false, the only way for the ground to stay dry, is if either it doesn't rain, which means premise 2 is false, or if raining doesn't lead to the ground being wet. Right? So this first premise, we're going to talk about these more as we go, but this first premise is what we call a conditional. Right? And the idea is that it's giving us a connection. It's telling us, hey, when it rains, the ground becomes wet, right? So like, in order for this to be false, we would have to say, hey, it could rain without the ground being wet. So, or that's what that sort of statement would be if it were to be false. Well, again, we'll talk about these more as we go. But so the idea in this case, just to say it one more time, is the only way for this conclusion to be false is if either premise 1 is false, raining doesn't lead to the ground being wet, or premise 2 is false, right? It's not actually raining. So the point of all this is, so let me write this down just because sometimes that's more helpful for some people. So the only way for the conclusion to be false is if either premise 1 is false, rain doesn't always lead to wet ground outside, or potentially and, right? Well, why didn't you make that one go to a... Or premise 2 is false, right? It's not actually raining. But if both are true, then the conclusion would have to be. Right? This is what we mean by validity, specifically for this argument, right? In terms of rain and whatnot. But like, see that connection here? Right? The only way this conclusion could be false is if one of these premises were false. Now, just so we get the idea, I won't do this for every single argument. That would take a while, right? The point is we'll see a pattern pretty soon. But I do want to just like show you real quick, compare this one to another argument. And you could even watch how I change it. So all I'm going to do is I'm going to take this. I'm going to put it right there. And I'm going to take this. I'm going to put it right there. So the point was, I'll send this away a little bit so we can just focus. So, right, I changed the argument slightly. Now it's a new argument. Now instead of trying to justify that the ground will be wet, now this argument, just so we can see, we're just comparing two totally different arguments here. So now this second argument here is trying to justify, hey, it is raining. Why is it raining? Well, if it rains, the ground will be wet, and the ground is wet. Therefore, I think it's raining. Right? This is also an argument. And you might even like have heard someone say something along these lines. You might hear them say, hey, it's raining. Why do you think it's raining? Well, the ground is wet, right? I mean, look up, how about? But, right, like that's one way to try to justify it's raining. But, like, notice, this one doesn't actually, this one's not valid in the same way that this one is. Right? Over here on the right, so to be clear, right, this is a valid argument. I hope that was nice and explicit, right? So this is valid. Can we add in a little? Oh, oh, okay. Okay, So, right, so this one's valid, good. But this one over here, right? Suppose the ground being or suppose it raining means the ground is wet, and suppose you see the ground is wet. That does not mean the ground that it's necessarily raining, right? By those premises, maybe sure the rain might mean the ground might make the ground wet, but it might also be that the ground is wet because you threw a bucket of water on it, right? Or you're in a pool area or something. Right, the ground can be wet for a number of different reasons. Or right, yeah. So that means it doesn't necessarily follow that it's actually raining. So I'm going to copy and paste this note over here now. So this is about invalidity. So let me just rewrite this whole thing. So the conclusion can be false. It's not raining. Even with both premises being true. Rain leads to wet ground. And the ground is wet. But the ground is wet some other way. Okay. Right. If both premises are true, the conclusion could be true or it could be false. So that's an important thing we might not have spoken enough about, actually. Right. An invalid argument isn't one where the conclusion is necessarily going to be false, right? That would just be like you have a valid argument in hiding. You just need to change something slightly. An invalid argument is one that just doesn't have the power to actually guarantee the conclusion, right? Like it's just left hanging. Like maybe it's raining outside, maybe it's not. Like you haven't given me enough information in those premises to know whether or not it's raining, right? So, okay. So we have a valid argument on the left, an invalid argument on the right. Right, where invalid just means not valid. And let me go ahead and switch that. Okay, cool. All right, so that's just a quick reminder a bit about how this works, about what we're looking for in validity, that we're looking for this idea that, okay, I don't care if the premises are actually true, but if I were to imagine they're true, do they leave any possibility for the conclusion not being true, or do they guarantee it, right? We don't want to just make it okay and possible for the conclusion to be true. We want to see if those premises guarantee the conclusion. Okay, so let's look back now. We'll look at this one here. I'll go ahead and bold it just to make it more clear what we're focusing on. So if a person is human, then they are mortal. Socrates is human, so Socrates is mortal. So this one, I won't spend much time on a lot of these, but won't spend much time on this one because, well, we already have, right? This is basically the same thing that we've been looking at a few times over now, right? We've changed it slightly. Socrates is a man, all men are mortal, but it's essentially the same thing, right? We're saying being a person, being a human means you're mortal. Socrates is a human, therefore Socrates is mortal. Okay, cool. So this one is also valid, so maybe I'll scoot this up here. I'll take this, and I'll just put it right there. Oh, don't need that there. And then I'll, just to be consistent. Okay. So we can put the valid stamp next to this one as well. So what about this one? So if a substance is water, then it is made of H2O. This substance is water, it is made of H2O. Okay, so I mean, maybe you're starting to see the pattern here, right? But like, let's just maybe think through it one more time. Why don't you want to not be bolded? There we go. So if a substance is water, then it's made of H2O. This substance is water, it is made of H2O. So the only way that this thing, whatever it is not made of H2O is if, well, either it's not actually water, or being water doesn't mean you're made out of H2O, right? But again, what we have is another valid argument, right? We know that if those premises are both true, if being water means you are H2O, and this thing is water, right? Whatever it is that we're referring to, then we know it must be made out of H2O. Okay. And you might also see, like with all of these, we can do the same. Well, we'll talk about this later, but we can play a similar game we did before in trying to find invalid arguments too. There's a reason. The reason why I showed this is just to remind you, it's not that all arguments are going to be valid. I just have these built in a very specific way. So, okay, now let's look at this next one. If a program is running, then it must be in the memory, right? In your phone or your laptop or your computer or what have you, right? In its memory, in its RAM. This program is running. Let's say, maybe this whiteboard program is running. Therefore, it must be in my memory, right? In the computer's memory, right? So the only way for it not to be in the memory, again, the only way for the conclusion to be false is if either the program isn't actually running or a running program doesn't necessarily need to be in the memory, right? If one of those fails, then sure, it might not be in the memory. But if both of those are true, then we have to accept that conclusion, right? So we can call that one valid. So you might have started to see a bit of a pattern, right? In each of these, what I'm doing is I'm saying if something is true, right? Now let me go ahead and color this. Let's use purple here. If something is true, then something else has to happen. Let's use red. And then I say, yeah, no, this something is happening. Therefore, that other thing that I mentioned, right, has to happen. Right? That's exactly the same thing as what happened up here, right? I'm going to use the same structure, right? So the point is, here I said, if purple, then red. Purple is indeed true. Therefore, red has to be true, right? And we can do the same thing for each of these up here, right? The form is actually the same, right? If a substance is a water, so if purple, then red. This substance is water, right? Therefore, red. Right? Same thing above. If a person is a human, if purple, right? Socrates is a human, then they are mortal, red. Socrates is mortal, red. And then finally, right, if it is raining, or if it rains, purple, the ground will be wet. Red, it is raining. Purple, therefore the ground will be wet. And then let's compare this. So right, well, let's take a second just to see. If purple, then red. Purple is true. Therefore, red has to be true. Right? So the first premise in each of these is giving us just this conditional. It's just giving us this connection between if purple, then red, right? If A, then B. And then premise 2 has nothing to do with B at all, right? It doesn't say anything about red. It's just, right? It's just telling us, oh, purple is actually happening, right? Purple is actually true. And so because we know we have A, we have purple, and because we know purple always leads to red, then we know red has to follow, right? The only way for red not to follow is if either purple doesn't lead to red or purple isn't true in the first place, right? Now, notice how that's different from over here. Let's do the same sort of thing. So if it rains, so I'll make the conditional exactly the same, then the ground will be wet. The ground will be wet. So that, right, that matches the red part. That doesn't match the purple part. So, right, we have if purple, then red, and then red. I should do this as well. Therefore, it is raining. So notice that the difference between this valid and this invalid argument, like in particular these top two, is that they have different forms. right? In the first one, if it's if A then B, A is true, therefore B is true, right? Because I just told you A leads to B. In the second one, we're saying, yeah, A leads to B, and we know B is true, but it's not the case. We don't know whether or not A is true. We don't know if it was A that caused it, right? So it's this sort of thing we're trying to separate out, right? So let me go ahead and write those. So I'll do it like this just to save a little bit of time. And now I can just B, A, if A, then B. Right, and then this one is just if A, I'll move it over, then B, B, therefore A. Right. Okay, and so the important thing to notice here is just that it's this form that's going to be really important. Let's look at the rest of our arguments and see how does this form match up, right? And so, like, if we just look at the next one, if John breaks the law, then he will be punished. John broke the law, therefore he will be punished, right? If A, then B. A is true, therefore B. The only way John won't be punished is if he either didn't break the law or breaking the law doesn't lead to punishment, right? One of those would have to be false in order for the conclusion not to happen, right? So again, this argument matches. This argument is again valid. It matches this valid structure, and as we'll see, like anything that matches that structure is going to turn out to be valid, right? Because we can think about it just in the abstract right here. If A, then B. A is true, therefore B. So the only way for B to be false is if either A doesn't lead to B, or if A wasn't true. But A being true and A leading to B together would entail that B itself is true. Right, okay. So again, I'm going to go ahead and try to get through the rest of these somewhat more quickly. So if you eat healthy foods, then you will improve your health. You eat healthy foods, therefore you'll improve your health. The only way you don't improve your health is if either you didn't eat healthy foods, or doing so doesn't necessarily improve your health. Okay, if a company increases its marketing efforts, then its sales will increase. The company has increased its marketing efforts, therefore its sales will increase, right? So the only reason that this could be false is if either they didn't increase their marketing efforts, or increasing your marketing efforts doesn't necessarily lead to a sales increase, right? But the idea is having this as a valid argument narrows down. Okay, well, if this didn't happen, we know exactly it was either because you didn't do this, or because that doesn't actually have the consequence you think it does, right? But again, this has this valid form. Let me go ahead and put these valid stamps on each of these. If Carla studies hard, then Carla will get good grades. Carla studies hard, therefore Carla will get good grades, right? So again, we have this valid structure. The only way she doesn't get good grades is if studying hard doesn't actually lead to it, or if she didn't actually study hard. And then finally, if an action is morally right, then it should be done. Helping others is morally right. Helping others should be done. Again, so the only reason helping others shouldn't be done is if either it's not morally right, or if being morally right doesn't entail that it should be done. Right? And this last example is a good illustration of also like how, yeah, arguments, we can be talking about morality or any of these subjects that we've been dealing with throughout, right? These are content neutral. It doesn't matter that we were talking about, right, Carla studying or eating healthy foods or breaking the law or running or H2O or whatever, right? The point is this form worked for all of it. So this is what we mean when we say logic is content neutral. So it doesn't depend on the content. It only depends on form/structure. So this is why, and we'll be talking about this much more next week. But this is why early on, when I said something like, well, a statement like, well, this person went to the Broncos game because they're a fan, that's not necessarily like what we mean by logic typically, in the sense that that would be like having just this argument, right? Just, well, one, he's a Broncos fan. Two, therefore he went to the game. It's like, well, no, something's missing here. That's not actually logical. What you need is to say, if you're a Broncos fan, then you go to the Broncos game. He's a Broncos fan, therefore you go to the Broncos. Right? Like, the point is, in order to make this logical, we need to be able to spell out what the inference is and what are all of the necessary parts. We don't want to leave anything in hiding, and that's exactly what we were doing, right? We left implicit this connection between, well, fans always go to the game, right? So in general, what we want to be doing is we want to get very clear on what these inferences are, right? And when we do that, what we'll be able to see is it's often, well, I shouldn't say often, it's always, especially in terms of this particular logical format that we're starting with, in terms of this structure, right? It's about if A, then B, and, well, A, therefore B. And how that's a different structure than if A, then B, and B, therefore A. And so these are our first two structures that we can, right, distinguish between. But what we're going to be doing for the rest of the course is really getting a better sense of that, right? Really getting a better sense of, well, there's a lot of other structures, right? What about all A's are B's, all B's are C's, therefore all A's are C's, right? There's another structure. We could come up with countless other structures. So this is our first set of them. And what it shows us is that, right, just logic is, in general, right, we're going to be setting aside the particular content, and we're going to be moving into thinking about it just in terms of the format, just what's the pattern of the reasoning, right? How do all the blocks fit together, not necessarily what do the blocks themselves say. Okay. So just last couple of things. The idea is this, sometimes you may hear about this name, so let's go ahead and name these. So this is called modus ponens. And again, like, I won't be quizzing you on this particular name or anything like that. It's just that you will very well see this from time to time around, whether in this class or in other places now that you're taking a logic class. Modus ponens is just one of the most famous valid forms, and it is very much it's just this if A then B, A is true, therefore B is true, right? It's just a very straightforward, logically valid structure for an argument. Whereas this other one is what we call a fallacy, right? So here, let me first say, this is called affirming the consequent. So the idea is, and again, we'll talk about this more later, but this thing up here is called a conditional, right? If A, then B. And B is what we know is what we'll call the consequent, right? It's like the consequence of A, in a sense. And so the idea is, what's happening here is you're affirming the consequent. So you're saying if A is true, then B is true, right? If it's raining, then the ground is wet. And instead of saying, hey, it's raining, like the left side does, you're saying, oh, the consequence is true. And then you're making the false inference into saying, oh, that means the antecedent, we'll give these names later, the antecedent is true. The first part is true, the cause, if you will, right? So the idea is, this is just a fallacy. It's invalid, but it's an extremely popular fallacy. I hear this, you'll hear this, people make this fallacy all the time, right? They'll say, well, if this were true, then that would happen. And I saw that happen, so it must have meant that was true. And it's like, well, no, that's getting it backwards. You told me if this happens, then the other thing happens. But you didn't tell me that that other thing can't have happened in a number of different other ways, right? So modus ponens, we'll just say famous valid form. Okay. So just to be clear, one final note on these. So before I say that, actually, so with all of these, we could swap the purple and the red for each one of these arguments and create an invalid argument, right? We could say, okay, take this, put it over here, and then swap out this sentence for that sentence, right? And we say, if John breaks the law, then he will be punished. John will be punished, therefore John broke the law. And the idea is, well, not necessarily. Even under these premises, John might not break the law, but he still might be punished. Maybe he has the wrong friends or something. And if John breaks the law, right, and it still might be true that, yeah, breaking the law makes you punished. And it still might be true that, yeah, he's going to be punished for one reason or another, but his reason for being punished might not be that he broke the law, right? So just giving you an example for, right, just how this, right, so for any argument, we can think about just changing that structure, and what we get is an invalid argument. Okay, that last point I wanted to make, though, now let me just make that, is, so to be clear, statements, as in premises, conclusions, actually let me just say, and conclusions, are true versus false, and arguments are valid versus invalid. So this note will be more important for us to bounce back to as we go, probably, because it's just the sort of thing that a lot of people will start to slip up on as time goes. But the idea is, we never want to say, for us, we don't mean that we never want to say a statement itself is valid, right? The idea is, when we're talking about validity, it's always a feature of an argument. It's always a feature of, do the premises of an argument connect to its conclusion? But a statement alone is not like a connection of premises and conclusions. It's just one little piece. Statements on themselves are either true or false, and it's arguments which are valid versus invalid. So just to be clear on that as we go forward. Okay, as always, let me know if you have any questions, and stay safe out there.